Good evening, everyone. My name is Sam Nasser, and this is the Azure Cleveland User Group. A little bit about the group. We meet every second Wednesday typically. The meetings are free of charge and open to the public, and we cover a variety of topics related to Azure. You can find the meeting information posted at meetup.com at the link listed at the bottom of the slide. Some general information before we get started. First and foremost, participation is always encouraged. And I always say the only stupid question is the one not being asked. We also want to keep it casual but organized, so jump in with any questions or comments. But at the same time, we want to give enough time for our speaker to go through all the demos and the presentation slides. The presentation will be recorded and will be posted on YouTube in just a few short days after the editing process. Also like to mention a special offer from Manning.com. We get 35% off at their website using the discount code MTPCLEC21, and the link listed at the bottom of the slide will be made available in the chat. Tonight's presenter will be Jeff Palermo, talking about Architect for Azure Container Apps and .NET 7. Jeff is the Chief Architect of ClearMeasure. He's also been a Microsoft MVP since 2006. And you can find him at various conferences and user groups. He has spoken at national conferences such as Ignite, TechEd, Visual Studio Live, and DevTeach. He's also the founder of several user groups and has authored multiple books, videos, and articles. And as if that's not enough, he's also the host of one of my favorite podcasts, the Azure DevOps Podcast, available at the URL listed below. And so without further ado, Jeff, welcome back.
Thank you, Sam, for the warm introduction. I appreciate it, and it's a pleasure to be here at the group. I think as we go along, just technology-wise, I'll key up the questions, type them in the chat or the question, and we can have a good, robust discussion kind of after I get through the demo and the quick material here. And just to frame it, this talk is about Azure Container Apps. Okay, we're building .NET software, and Azure comes out with this new thing called Azure Container Apps. So what is it? What should we think about it? What's new? What's not new? And how do we best leverage this new technology? What does it even look like? There's a lot of existing stable technology out there. .NET 6 long-term release, .NET 7 is the new one, but there's just a little bit added onto it. But really, .NET 6, 7, kind of the same things. Performance improvements in .NET 7, but as far as APIs, pretty much the same. C#'s been around for a long time. SQL Server, a long time. Azure queues and topic subscriptions. Azure App Service is probably the most used Azure offering besides just VMs. And then in Kubernetes, which Azure has embraced, and the entire cloud world has embraced. That's been around for a long time, and that's proven. But as technology moves forward, we also want to integrate new things. And so Azure Container Apps is one of these new things, but it's not completely new. It kind of layers on some existing concepts. And we're going to look at that. We're going to look at Azure Container Apps, what stays the same, and what actually is new as we go through this. So just a little bit about me. I'm a chief architect at ClearMeasure, and we're a software architecture company, and our mission is to empower software delivery. There's plenty of consulting companies out there and dev shops that want to build a piece of software for their customers. We serve customers who have decided to have internal software developers. And our goal is to make those teams really, really effective. That's what gives us joy. We want the in-house teams to be self-sufficient and moving fast and delivering top-notch quality and ultimately achieving a high level of stability in running their systems and operating them well. And we focus on the Microsoft platform. We're also the North American implementation and consulting partner for Octopus Deploy, which is, in our opinion, the best automated deployment tool, really integrated with any build server. That's a little bit about us. Free offer. My latest book is called .NET DevOps for Azure. which is all about how to ship .NET software, what the process should look like, what's the empowering environment. If you send me an email, then I can give you a free electronic copy of that book. So you can also find the print book anywhere print books are sold. But go ahead and do that. All right. Let's get on to Sam. You already talked about the Azure DevOps podcast, so I'm not going to really talk about that much. But you can also find a new video podcast called Programming with Palermo, and just search for that, Programming with Palermo, and you'll be able to find it in any of the podcast directories as well as YouTube. All right, so let's level set a little bit. I'm going to go really light on .NET 7 because Azure is more interesting. But just know that the demo app that we're going to show it is .NET 7. If you haven't even touched .NET 7, it's a short-term release because .NET 8 is going to come out this November. It's a seamless upgrade from .NET 6. Really is. There's not a lot of API breaks, and they really worked on performance under the hood stuff. And so performance is really, really improved. For people doing ARM processors, there's a lot of improvements there. For people doing the frameworks that depend on Mono, like Blazor WebAssembly and Maui for smartphone applications, you got the new version of C#, C# 11, which has static virtual methods in interfaces that empowers generic math. But it's actually a really interesting new feature of C# that I've kind of beat my head against in years past. And I think it's a really interesting and welcome interface to be able to have interfaces that have static methods. And so when a class implements an interface, that class automatically gets a static method with the implementation. And then also .NET.exe is coming out with a new version of the publish command for containers. Now, first version, they're still working things out. I would not say go and immediately start using it, but Microsoft has announced that they believe containers is going to be so ubiquitous that they're building in the tooling for creating Docker container images, and they're making the tooling so that for .NET apps, you don't even need to draft a Docker file. That's one of those files where it's like, why do we have this extra file? I don't even want to use Docker. Early in containers, Docker and Docker Desktop and Docker Swarm and all these things were a thing. And then Kubernetes kind of, took over the container world. And really the container format was created by Docker, or the format that won out was created by Docker. So we say it's a Docker container, but it's less and less important that it be Docker. It's just a container. So they're taking the format, they're kind of building it into the tooling so that we can containerize .NET applications without having to worry about drafting our own Docker file. Because for the most part, the Docker file is pretty darn standard. I'm going to show you what our Docker file looks like for this sample application. And there's nothing magical about it. So it's pretty cool that they're going to just take away the requirement for having a Docker file in the first place. So look for that. All right, Azure Container Apps. I'm not going to go into what containers are, and I'm not even going to go into what Kubernetes is. So if you've never even looked at the structure of Kubernetes, you probably want to just watch some intro videos. But my rendition of Azure Container Apps, in light of Azure App Service, is it's an experience very familiar to Azure App Service, but under the covers inside the Azure Data Center, Azure Kubernetes Service is actually serving everything under the hood. Because for certain situations, you want to use Azure Kubernetes Service, but there's so many knobs, there's so many buttons for a whole slew of .NET applications. Kubernetes in general is just not necessary. And so Azure Container Apps, what Microsoft is doing is leveraging the power of Kubernetes as part of their Azure. Think of Azure as an operating system for a data center. Whereas Windows servers and Linux, they're operating systems for a particular server machine. Azure is an operating system for a whole data center. And so what they're taking is they're taking Kubernetes and they're adding it to that Azure operating system. And Azure Container Apps gives us the ability to take a .NET application, ball it up inside of a container, and throw it at Azure and say, hey, please run this. And Azure says, okay, I got it. And now under the covers, you got Kubernetes doing interesting things, but we as developers don't have to know how to tune all the knobs and press all the buttons to actually get that to happen. Some of the interesting features for Azure Container Apps is dynamic scaling. You got the secrets dictionary, and also for pricing. On the low end, it's super, super, super cheap, super affordable, because you can scale to idle, where it barely keeps your application in memory, ready to server request, with no compute being used, or scale to 0, where it literally puts it to sleep, and you literally pay nothing except for storage, which is almost minuscule, absolutely nothing. Now, what's interesting in the dynamic scaling, yeah, they have some built-in things like HTTP traffic and Q-link, but what's interesting is the CADA metrics. CADA stands for Kubernetes Event-Driven Autoscaler. Okay, Kubernetes Event-Driven Autoscaler. That's something that's built into Kubernetes. So if you've never used Kubernetes before, that's one of those concepts you don't need to know, but that's one of the autoscalers that's just built into Kubernetes that we take advantage of, because Azure Container Apps is built on top of Kubernetes. And Microsoft has made a custom CADA scaler, one of the 56, a custom CADA scaler for Azure Monitor metrics. So anybody that's used Application Insights, and you've just used the Application Insights C# wrapper, the C# library wrapper, to create a custom metric. And certainly in Blazor applications, custom metrics are pretty popular. How many people are currently using my Blazor application? Because it's a resident, more web-based smart client application. Publish it to Azure Applications as a metric, and now you can point your CADA scaler at your Application Insights, which is part of Azure Monitor, point at that metric value and say, when it gets above a certain number, I want you to spin up a second instance of my container. All right. And so now effectively, if it's a web type thing, you have a second instance of your web application. So in container land, it's kind of similar to having a second server in your web farm. You have a second container. All right, so that's pretty cool. I think that's one of the ahas, is that, oh, if I have these custom CADA scalers, and one of them is Azure Monitor metrics, you basically implement Azure Monitor with those metrics with just C# logic. I now can programmatically scale my application with C#. And so literally, whatever my imagination comes up with, I can have that be a base of scaling, and I don't have to write PowerShell or use weird rules in Azure and all these other ways that there's been to scale. So that's pretty interesting. All right, so I said that this is built on top of Kubernetes, and so just real quick, I want to highlight some of the concepts of Kubernetes inside Azure, and these are just three different views. We have the Kubernetes cluster, and in Azure, already there's things that we don't have to manage up on the top left. We don't have to manage the DNS. We don't have to manage the kube proxy. We don't have to manage the Kubernetes dashboard. We only have to worry about our pods and the containers of those pods. You've got the schedulers. There's all kinds of these things that Kubernetes has, and it's a learning curve. Even to the point of deciding, how many nodes do I want to be in my cluster? In other words, how many servers do I want to be in my cluster? And every one of those nodes needs to have the kubelet service, which is just another container that's running that helps to figure out all these container pods, okay? And under the covers, of course, all this is running on Azure virtual machine scale sets. and Azure is managing the virtual network so that we have our own IP address range, and it's storing everything in Azure disks and Azure files. So Azure is already doing a lot, even if we were to use the Azure Kubernetes service. But we don't need all those knobs. So now on top of this, just so you know what's running under the covers, on top of this, Azure Container Apps just lets you focus on the pod. Okay, so there's two concepts, and when we get to the Azure portal, I'll show you. There's two concepts in Azure Container Apps. There's the Azure Container App environment, and then there's the Azure Container App. You can have more than one app inside an environment. A container app is equal to a Kubernetes pod. Okay, a Kubernetes pod can host. It typically hosts one container image, but can spin up and have multiple instances of it. You can host multiple containers. You can host multiple different types of containers inside an app. Now, a Kubernetes pod is kind of your boundary of networking and a boundary of security and also resources. So if you have a container in the same pod, you know under the covers that both of those containers are going to be on the same virtual machine in Azure. And so the networking, it's literally going to be localhost. And so if you're thinking about the architecture of your network and resources and all that, you can rely on two different containers running in the same pod, being on the same server. All right. And then the Azure Container Environment is just another networking boundary. I'm not going to go into detail about this, but let's go to the actual demo application. Let me just show it to you real quick so that we know what we're talking about. All right, so in Visual Studio, and by the way, this is in GitHub, so I'll share those links with you when at the end of the presentation. Anybody can go there. This is just a regular, super simple Visual Studio application. It doesn't have a lot of features, but think of it as a projector app. Think of it as an announcement app for projection. It's called Church Bulletin app. Things that are going on at the church, your Sunday school groups, your Bible studies, the Easter facility schedule that's coming up, whatever it happens to be. But from a data perspective, it's super simple and it's a skeleton application. And let me just Control F5. Let me run this app just so you can see what it looks like. Can't open the screen. All right. Hello, Azure Cleveland. Looks pretty darn simple too, right? Has the weather and then a single page, different things that are going on at the church, sample data. All right, not much there. It's a simple Blazor application. And one thing that we have added that I actually like to add to every application is a version is a version URL where we can just tack on /version and I didn't put it there /version and local development. We don't even have a version. It's 1.0. But when we actually go to our environment, we're going to look at that. All right. So let me drop down and let me show you in our global JSON. We are running version 7, okay? And if you go to this GitHub repository, you will find here a build script for GitHub Actions, and you will also find the Azure Pipelines.yaml file that controls the build, and we'll dig deeper into this because this has the container image stuff into it as well. So this has the build where we're setting up PowerShell. We're actually putting in an environment variable for the version of the build number, okay, because that's important to stamp literally everything with the version number. We are I'm not going to. This application is also has some integration with Octopus Deploy deployments, which is out of scope for this presentation, but we've used this application for Octopus Deploy presentations as well for automated DevOps. But right here is where we actually run our build script. I am an advocate for having a private build script that is a PowerShell file in your source control rather than just having Azure pipelines do compile and test, because YAML is not a good programming language. It's just declarative markup. And when you have logic in a build script, and I'll open that up right here, build.ps1, PowerShell is a much better scripting language. YAML it's almost like it might as well be JSON or XML. It's just another markup language. Markup languages are not good for code, whereas PowerShell is a type of code. All right, so this is PowerShell. We just kind of clean things up, get ready, get rid of old build artifacts. Then we do our compilation .NET build. And by the way, if you want to steal this build script and use it for any .NET application, I actually encourage it. This build script is super old. So many people have contributed to it going back to, I think, 2005. This version of this build script, I kind of went in depth in my latest book, .NET DevOps for Azure. But there's so many things. Like when you're doing a compilation, you don't want to let the tooling do yet another NuGet restore. You've already done a NuGet restore. It's just time wasted. And then you also want to treat warnings as errors. And you want to do it at this level. Treating warnings as errors in every single project in Visual Studio is actually a hassle. And that's why developers don't do it, because they're in the middle of something and they need to get something working. And Visual Studio is saying, you have a warning, fail, fail, fail. And they're like, I got it, I have a warning, but I just need to get this working. And so while you're iterating locally and you're trying to get stuff running, I don't blame developers for turning off warnings as error. But then they forget to turn it back on when they actually go to commit the code and share it with the team. So it's much better to turn on warnings as errors at the build level in your build script for the entire solution than to have that be always on for every single project, even when you're in the midst of coding. And then, of course, you want to pass in your version number so that all of your assemblies get tagged. All right, that's a whole other thing. But we have our unit tests, we have our integration test project, we have our acceptance tests, we have database, and then we have packaging up. And so for packaging up, notice that we are using .NET Publish so that our top level web project, which is a Blazor WebAssembly, we've split out the client WebAssembly, and we've also split out the web services so that we actually have a top level project here. But scroll by down. We're using .NET Publish. This is important because now the next step is going to be creating the container. So if we say .NET Publish and package, then we are basically creating a directory that has everything necessary. Okay. All right, that's everything necessary. And then we're using .NET-Octo, which is a really good NuGet wrapper to wrap this up in a NuGet package. Now, that's important because let me show you the next step that would happen in our chain. And the next step that would happen is to push that into Azure Artifacts. All right, so we have churchbulletin.ui, we have our SQL Server database for deployment, which we're not going to go in today because we're talking about container apps, and then our acceptance test, a test suite that needs to be deployed to our test automation environment so that we can run the right version of our full system test suite against the right version that we just deployed to that test automation environment. All right, so that's where we go from there. Now, let me just show you the build, kind of what it looks like. And we have 1.1.48, which is ready to go. And there are two different jobs, build and Docker build and publish. So build, I just went through where we're running our build script, we're publishing our test coverage. Now let's go into Docker build and push. These need to be two different jobs because they actually run on different operating systems. For the build for .NET and various tooling that you have, it's super convenient to run it on a Windows server. Now, can you run it all on Linux? Absolutely, you can. But there's so much software that just for the development environment has and maybe the testing has a Windows dependency or something that just runs a little bit better on Windows. And so you have the power to run them on separate operating systems. When we go to build and push, this actually runs on a Ubuntu latest. That's the agent. And so what we're going to do is we're going to check out the source for scripts and tooling just so that it has the Azure Pipelines YAML file. But then we're going to download a package from Azure Artifacts, and I'll show you that detail again. Then we're going to create our Docker image using the Docker file, and that's kind of what it's doing there. I'm not going to go into all the logs. And then we're done. Okay, so let's go back to Visual Studio and go back into this Azure Pipelines YAML file. Because I showed you that there were 2 jobs, right? Well, here is the second job, Docker build and push. And we're using Ubuntu, and then we're going to actually download our web application, which is churchbulletin.ui, and that thing right there is going to be a NuGet package, and we're going to download the NuGet package and explode its contents. We're going to unzip it to this directory, okay? Then, for our Docker task, we're going to look for a container registry called that, which we've created in Azure Pipelines. And we're going to look for a repository called churchbulletin.ui. And then we're going to use its built-in command build and push using whatever Docker file it finds. That's the asterisk. And we're going to give it a tag of the build number. Now, I'm going to come back to the tags, but let's look at the Docker file. We have a Docker file right here, and this is absolutely the simplest Docker file ever in human history, and Microsoft is doing work to make this file completely unnecessary because most files just have a boilerplate Docker file like this in the first place. What are we doing? We're using Microsoft's baseline pre-prepared .NET 7 image. Super simple. And we want to expose port 80, and we want to, and of course, port 443 and whatever port you want to do, and standard work directory, copy a local directory to the standard work directory. This right here is actually just diagnostics so that in the logs, we can make sure that we have a log of every file and directory in there. Okay, that's why ls is list. And then the entry point is going to be the assembly, ui.server, boom, right there, ui.server, which is the standard Blazor web application entry point. .NET run, boom, ui.server. Okay, simple as that. So now let's go into let's level set a little bit before we go into the Azure portal. All right. So this is the application shape that I showed you in Visual Studio. It's using the onion architecture dependency management mindset, where you have a core project that doesn't reference anything like Entity Framework or any third-party dependencies, and then all of your projects reference it. So instead of core referencing data access references core, and that enables your web services, your WebAssembly to not actually reference Entity Framework. You notice UI.API, which our API is what actually call the database, but they call the database through an interface in core that data access implements. That's outside of the bounds of this talk, how to use the services collection and dependency injection. But this is the shape of the application that we just looked at. This is the process that we're working within for an automated DevOps environment. I think I just saw that question. Is there a GitHub where you could download this project? Yes, there is, absolutely. And I'll give you that URL verbally, github.com/clearmeasurelabs, and then you can find the Onion Container Apps repository. But yeah, if you want to jumpstart now, github.com/clearmeasurelabs, and I think it's one of the top repositories. All right, so this is the process. We've kind of gone through the build, the integration build, how we're packaging and putting our release candidate packages in Azure Artifacts, and we are deploying to our first line our TDD environment, which is our test automation environment for those full system tests that we're going to run. I'm going to skip over and kind of ignore the rest of it because I want to focus on Azure Container Apps. But by the way, if this is kind of the first third of a DevOps architecture poster that we use a lot, if you don't have this and if you are interested in a high resolution version of this DevOps architecture poster, just send me an email and say, hey, can I have the poster? And I'll be sure to send you a high resolution PDF copy of it. It's really meant to go to a print shop and print on 2 foot by 3 foot paper or poster board, but certainly, blowing it up on your monitor. And I mean, just the top third of it right here, it has literally every step that needs to be in every part of an automated DevOps environment for any .NET application. All right, but let me skip through that. So for Azure Container Apps, there are some things that you have to think about when you're structuring your Git repositories, when you're structuring your source control. And one of those is that you want to make sure one Git repository has one software application. Okay. I didn't say one Visual Studio project or one deployed process. I said one application, because we know that it's perfectly fine to have an application in a Visual Studio solution. Typically, one Visual Studio solution should be mapped to one logical application. It's perfectly fine to have one application that contains a public web application, maybe a backend admin application, maybe an offline service or service worker of some sort, maybe a SQL Server database. Right there, you've got 4 things that have to be deployed. Okay, so it's perfectly normal to have multiple things that have to be deployed that are all a part of the same application, and they're all in the same Visual Studio solution. Okay, one Visual Studio solution like that in one Git repository. And so this is one of the mistakes that people make when going after a microservices pattern. They take a software system that might be too big for one Visual Studio solution, and they start kind of breaking it up and putting multiple Visual Studio solutions with these different autonomous services, but then they put it into one Git repository just separated by folders. And the problem is every build server, every automated DevOps tool out there is optimized and built and tested to work the best when it's operating on everything inside of a Git repository. Yes, you can bend them to your will and make them ignore so much of the Git repository and only focus on one of the trees, but they're really made to work on one Git repository. So that's optimal. And if you're going to break up a software system into and sprout off 10 different microservices, that's great. Sprout off 10 different Git repositories, and each of those Git repositories has one Visual Studio solution, and that Visual Studio solution has whatever needs to be deployed for that microservice, which I think our industry has reinforced that microservices are autonomous. So a microservice has whatever it does from a compute perspective, but it also owns its data. So a microservice will have at least 2 things to deploy. One is something compute that it does, whether it be visual screens or just a web service or a service worker, and it'll also have some type of data store to deploy, whether it's an Azure Queue, whether it's Azure Blob Storage, Azure Files, or a Azure SQL database. Okay, so that's how to think about this, because when we're going to containerize an application, we're going to containerize one of the processes to deploy. And so it's perfectly normal for a single application, which resides in one Visual Studio solution, to have say the database deployed to Azure SQL, but a web application that is bundled up in a Docker image and a container image, and then deployed to Azure Container App. And if you have multiple applications, okay, you might have multiple containers. Each one of them needs to be deployed to an Azure Container App, whether it be the same one or different ones. All right, I talked about build. I'm not going to go in deeply on here. but I will illustrate the portion of your standard build process that changes when you are containerizing a .NET app for Azure Container Apps, and that is right here in Publish, right at the very end. Okay, we've already done our version stamping. We're already compiling unit tests, integration tests. We've already run our static code analysis, and at the very end when we're publishing, that's the little step that changes that I showed you for containerizing. All right, so now we've got choices in Azure, and on the left, we have more control, but we have more responsibility, and that is our on-premise data center. And yeah, I've got the little octopus icon because Octopus Deploy is so ingrained with Azure pipelines and .NET applications. Probably the best way to deploy .NET applications, both on GitHub and Azure pipelines. But on the far right, Azure SQL, Azure Functions, pure platform as a services play. You have the most done for you. You have the least amount of maintenance, but you also have the least amount of control. And Azure App Service is almost over here. So the further you go to the right, the less control you have. Now let me give you an example with Azure App Service and Azure SQL and Functions. Azure App Service kind of right there with them. On Azure App Service, there's some applications that require custom barcode fonts to have something on the screen that a barcode scanner can scan. Shipping applications, whatnot. You cannot install a custom font on that. So that's the amount of control. If your application needs that, well, then you need to back off from there. And with Azure Container Apps, you can install all kinds of stuff. You can specify that all kinds of stuff be installed when your container is provisioning. So you're backing off a little bit from pure platform as a service. You're taking on a little bit of responsibility for configuration, but you still get a lot more done for you than an Azure VM. So that's where Azure Container Apps sit on the continuum. And I predict they're going to become as over time, they'll become as popular as Azure Container Apps because you get more control, but the maintenance that you have to take on is so small that it's not that much of a trade-off, as opposed to the trade-off of an Azure VM, where now you've got the entire Windows operating system that you got to manage and security patches and all that. All right, so I'm going to blaze through packaging. Because we're just going to ignore the rest of this application and we're going to focus on just the ASP.NET UI. We've packaged that up as a container and we have a release candidate package for it, and we're gonna deploy it off to a container app. And I've already showed you what it looks like in Azure Artifacts. This is what the full pipeline would look like if we were going through the whole stage. I'm just going to fast forward through this and get right onto the container apps. All right, let's look under the hood. Here we go. So I'm going to jump over to the Azure portal. Okay. And we are in a resource group for all of the resources here. What we have is, and I'm not going to go into every component of this, we have a SQL server, we have a SQL database because it's part of this application. Then we have a container apps environment. This is the first part of this new container app. Then we have a container app, okay? And go into the container app environment, which is right, which one was it? Yeah, this is the container app environment. So if I go to the overview, you can see it's in that resource group, and we have a static IP address for the container app environment. We have one container app, and there's a whole lot of here, but I'm going to jump straight into apps. Okay, I can have as many apps as I want. I can create a new container app, click, and I can specify what it is. It's just as simple as that. It's easy. Okay, I'm going to go back. All right, so we have one, and it's called TDD-UI. I like to, for segmenting, the Azure subscription is your security boundary when it comes to when it comes to managing applications. And so in any organization that's making substantial use of Azure, you are not going to have just one Azure subscription. You're not even going to have two. You're going to have many Azure subscriptions, and those boundaries tend to be organizational in nature. You don't want to have different teams that do not work closely together trying to share the same Azure subscription. You're just going to trip on each other, and the role-based security is going to get so confusing. You don't want to do it. You want to, we as an industry, we've been using Azure long enough to kind of have made some of those mistakes and whatnot. And so it's much easier to have a Azure billing profile for the organization so that the different departments that split their budgets can manage that. And then within that profile, you can have any number of Azure subscriptions that kind of get rolled up and the reporting makes sense. But what you do want to also make sure to segment Azure subscriptions on is production versus non-production. We've learned over time it's a bad idea to mix resource groups that have non-production resources into the same Azure subscription as resource groups that contain production resources, and especially the data. Okay, so when I say you can put multiple apps in the same container environment, what I would advocate you do is have a different resource group for one, your different applications, but make sure that you don't have those resource groups for non-production environments in the same subscription as production assets. That's just a little aside. All right, so let's say that this resource group is a particular application, and we want to have multiple test environments. You probably a lot of the time would choose to have a different resource group per environment. But definitely if you have multiple containers for this application, they would definitely go in the same container app environment, unless you really wanted to scale them differently. Okay, because if you think about it, your container app environment has an IP address. What does that mean? It means it's on the same node, which means you're dealing with a virtual machine scale set underneath. Okay. All right. So inside the app, let's click inside the app, go into it. Now we're inside a container app. So I would compare the container app environment with your app service hosting plan. Okay, you can have as many apps as you want for app service inside a hosting plan, but your hosting plan kind of gives you the size of the servers, some billing, it has a grouping. Now, what's different with container apps is the size of the CPU and memory is actually at the container app level, not the container environment level, whereas an app service, the CPU and memory is at the app service hosting plan level. So that is a difference. All right, we are in the container app, and now that we're in the container app, we actually have a URL to our application. Well, let's jump over to Control Click. Let's open that up, and notice it's opening up our Blazor WebAssembly application. Waiting for that took a little second longer than I thought. All right, so we have our application, yada yada. It works. All right. Remember, I showed you that /version. So version. Now we're in the deployed environment, 1.1.47, okay? 1.1.47. So if we look at our builds, let's go to the build configuration, 1.147. And of course, I made a sample commit just an hour ago, just to have an extra version to be able to deploy. Now, look at what we have here on home, hello world. Remember when I pulled it up locally, it said hello Azure Cleveland, right? All right, this was local, but it's not deployed yet. So we need to get it deployed. All right, so let's go ahead and do that. What does a deployment look like with container apps? Now, I'm going to do it through the Azure portal, so you see the mechanics of what's going on. Even though when you get into your actual team environment, you want all this automated. You want to be integrating Azure pipelines. with or GitHub Actions with Octopus Deploy, and you want to have this absolutely command line just happening by itself. Okay, but I just want you to know what's happening in the Azure portal, so you can kind of map the command lines to it. All right, I've shown you the application, and let's go into where this container actually goes, and we'll put the two together. All right. So in our build, Docker build and push, we basically are creating the Docker image. All right. And by the way, this is the standard Microsoft maintained image that we're just going to use. I'm grateful that we don't have to manage a whole bunch of stuff. Well, I'm not going to go into those details, but remember the /app and the copy build, and then remember this diagnostic. We're running this. Why? So in these logs, I can actually look at the files and directory that are being put into my image. And so you probably see some files that look familiar, right? Got that. Oh, churchbulletin.ui. That looks familiar. Yep, here's our ui.server.dll. That looks familiar. UI.client. I'm going to come back. App settings. Remember that in container environments, app settings is different than app service. A container image is immutable. So there's a very different deployment mindset that you have to have when deploying a container image than when you're deploying a published application to Azure App Service. With Azure App Service, it's very normal for us to deploy to a particular Azure App Service, say the staging environment, and then afterwards use a JSON poke command line or step template to actually poke in a variable into the app settings.json file. And then, of course, when we deploy to production app service, we copy files, and then we poke in a setting, app settings.json. With container apps, that's not the process. Container images are immutable. And so your app settings.json is going to be part of the image, and we are going to deploy the exact same container image to every environment, including production. And so we need to modify our application a little bit to look for variables in environment variables first, then app settings, and then our application settings that go with a particular build of the application, those are in the app settings.json. But variables that change from environment to environment, like database connection strings and other things that are different from environment to environment, we don't poke those into app settings. We push them into an environment variable, and then we configure the startup of the C# application to look for configuration in environment variables first, and then our app settings.json. So that's a little aside, kind of outside the bounds of this talk, but I just wanted to mention it so that you know that the usage of app settings is different when going to container apps from app service. Okay, so we've built the container, and then we are going to, where does it say push? We're going to push it up. Here's the repository. Yeah, we built, we tagged. Notice the build number 1.1.48. Okay, so we have a name for the container image, and we have a tag 1.1.48. All right, so preparing, doing some other stuff, and we're done. Okay, finished. All right, so now, well, where is it? What happens after that? Let's look for it. So over here, actually from our resource group, this is our container registry. All right, that's a resource. Just, create new container registry. They're dirt simple to create. And when you come in here, they're kind of empty. And then you create a new repository. So you can create, you don't create a repository through command line or the UI. When you push a particular container image to an Azure Container Registry, um, whatever the name is, that's basically, it auto creates a registry. Okay, so let's go into churchbulletin.ui, which is the name of our what we're deploying. So we have a registry for everything we're deploying. Go into that, and now we have a whole lot of images with the tag that is build numbers. Now, technically, you can make the image tag whatever you want under the sun. You can make stuff up, cat, dog, whatnot. But when you're doing automated DevOps, and I encourage you to do it this way, just make the tag the version number, because then you know exactly what you have. You have churchbulletin.ui, which is no mystery. It's this application that has been published and wrapped up as a container image, and you have version 1.1.48. And I mean, you could have, alpha versions 1.2. You don't have to go in order, and you can, any number of images, doesn't matter. But make the tag that. And if you click on the tag, you can actually see the manifest information of the container image itself for debugging, and see how it's put together. I've never used Artifact, and it's clearly in preview status. So anyway, that's that. Okay, so now we know where our container image is. So let's look at our container app. All right, I'm going to scroll past all this. There's so much stuff here. You can control networking. You would definitely put in any kind of passwords inside your secrets, and then custom domains. You can configure DNS just like app service. But I'm going to go down to revision management. All right, revision management and containers are the two things that you're going to use the most. All right, and once you deploy a container image to a container app, you don't change it. If you're going to change something about it, you're actually creating a new revision. Now, if I click over to this particular revision, and by the way, if you have a new version of the container, you create a new revision with the new version, you deploy it, you can actually load balance the traffic, and you can say, I want 50% of the traffic to go to this version of this container and 50% to go to another version, or 90-10. That's a cool feature that it has. And you can choose revision mode, where you can have only one active at a time, or you can have several revisions active simultaneously. If you want to do like application level A/B testing, and you want to have different container images with radically different navigation, and each of them reporting to application insights, what features they have turned on. This is another way to do feature testing. All right, let's open this up, and we can see the details of how many containers. But that's we can see that we're running image tag 1.1.1. Now that navigation is the same as if I were to come over here and click on containers, and there's only one container, so it's here. Environment variables, you're going to put whatever you want in the environment variables. Now, this right here is only for demo purposes. You can actually modify, and this should be a secret right here, and you can refer this environment variable to a secret. So if I were to want to change the image tag, and let's go ahead and do that. Let's go ahead and change it, and let's deploy 1.1.48. Now, normally I would do this with Octopus deploy, and it would call the appropriate PowerShell. Well, let's go ahead and edit and deploy, and we're just gonna use this as a template. If I hit add, I could add one without using it as a template, but most of the time, just for demonstration purposes, you notice we are using the registry that we're using, and we're using a particular image which lists all the different registries, which is basically image names. We're using churchbulletin.ui. Hello world comes kind of built in with the container app template. And now the image tag, I'm going to use 1.1.48. Okay, and I can change. Look at that. I'm running an application on 1/4 of a CPU and 1/2 gig of memory. the architecture that they have put together here, it enables such high application density on your servers, which are the Kubernetes nodes. Um, so it's absolutely insane. I mean, just for test applications, I mean, you may crank it up to half a CPU, half a virtual CPU, but you can do so much. And .NET 7 is so much more performant than .NET 6 anyway, which .NET 6 was, super fast. So our programming is really, really effective. All right, with connection string. Now, I change manual entry to reference a secret, and then if I select a secret, well, now I'm getting a particular environment variable from an encrypted secret. So that's the flow. Okay. And that's how our C# is looking for a connection string from an environment variable, and then container apps is fulfilling that environment variable with a value from an encrypted secret that uses the same technology, the same level of encryption as Azure Key Vault. So let me cancel that because I want to change it, and let's kind of do that again. Select our version. There we go. Let's hit save. Let's hit create. We're going to create this new revision, and it's deploying. While it's deploying, I have other levers I can do here. I can create replicas. I can add health probes, but while this is deploying, and it says it already deployed, it doesn't take very long. Let me go back to the let me go back to the application, and let me refresh, and boom, hello Azure Cleveland. All right, and I can go back to my /version, and it's telling me 1.1.48. So I have deployed a new version. I haven't changed anything about the container app. Actually, the only thing that I've changed about the container app is the image tag. If I make a new revision to this container and I change the image tag, then Azure under the covers is going to go to the container registry, grab the image, and is going to automatically do the swap out with the replicas, and it won't bring down the old container until it's ready to push up the new container. So that's pretty swift there. All right, let's kind of just wrap up here, and then we'll do any questions. There's a few quirks and gotchas that you have with containers, and I mentioned them being immutable. So you want to decide where to place the config keys, because if they change per environment, you don't want to put them in app settings. I talked about that image tag. Okay, pick a stable naming convention. I would advocate for the naming convention simply be the same build number that is labeled with your Azure Pipelines build number, with your GitHub Actions build number, and flow that on through. When you flow it through to Octopus Deploy, when you flow it through to Azure, then you have really good traceability all the way from source control and the build, all the way through everything deployed in every environment. I found that building code, running your build script on the hosted agents Windows latest works really good, and then building the actual container for the parts of your application that are containerized, that building on the Linux agents works really well there, and so that's kind of a good rule of thumb that really works nicely. We did some piloting, trying to build those containers on Windows, and the tooling is just kind of not seamless. So the tooling is really meant to run well on Linux. So that falls into place nicely. All right. I know that's a whirlwind of information, absolute whirlwind of information. Send me an email if you have any questions. And I love helping people. We do a lot of platform engineering and even architecture inspections and DevOps inspections and advisement. So give me a call if we can help. But let me turn to the questions, Sam, and maybe you can help filter those through if I pull up the chat. All right, and the question about the GitHub, the code, let's see if actually I'll pull up the URL right now so that everybody has the exact one. /Clear Measure Labs, and there it is. That is it. And I'll actually even copy this and paste it into the chat as well. And that has all of that code. It has the build template. It has the Azure Pipelines YAML, all that configuration. All right, so there's a question. Can the CPU utilization be auto-scaled depending on various conditions? Yes, there's a whole lot of, can the CPU utilization? Well, the way out of the box, and let me go back to that slide that covers it, because the number of containers is automatic with dynamic scaling. With the way it's designed, you pick an instance of the container and how much CPU you want to give it, and then you decide what the rules are to scale it down to idle or scale it down to 0, and then you pick what factors that you want to scale multiple instances of it. I'm actually not aware of a built-in scale setting that says, based on what it's doing, give it another CPU or 2 more CPUs or that. So I'm not aware of that angle. That's a really interesting question.
Well, not so much adding on additional CPUs, but more of increasing the utilization. So going from 25% to 50%, let's say.
Yeah, I'm not aware of a setting in Container Apps that gives you that knob. There may be, or they may be working on it. Maybe I'm something I'm not aware of, but I haven't seen that. I'll put up my email address since I referenced it a couple times. All right. Any more questions? Reviewing the. Yeah, and I put the GitHub into the chat so that y'all can grab the source and kind of look through and clone the repository, pull it down, and hit Control F5, run it locally, run the build, hook it up. Actually, if you take that repository, even if it sits in GitHub, create your own Azure Pipelines project, point it to there, and then just run it and do your own security configuration with a newly created Azure Container Registry in your own subscription. It'll run and put that container in your container registry. I mean, literally every command line, everything that's necessary to get to that point is in that Git repository. And then, of course, you can just play around with container apps and point it at that container registry and give it an image tag and basically do what you just saw me do pretty easy.
That was a very cool demo, by the way.
Thank you. Thank you.
We have one more question in chat. Rick is saying, maybe not the intent of your demo, but by deploying the database with a container, do you lose the ability to perform CRUD actions?
Okay. So in this particular application, and yeah, I'm not highlighting it in this particular demo. This application, the way it's configured is the web application is containerized and deployed to Container App. The database is not containerized and it's just deployed to Azure SQL. And so from a networking perspective, the Azure SQL networking and the firewall would be configured to allow connections from your container app, and then your container app literally just has a connection string at a network address that it can get to, and the .NET inside the container, you have Entity Framework that is issuing queries through the connection string to SQL Server, and everything's happy.
Thanks, Jeff. Yeah, that I didn't think that I'd heard the best practice was to avoid deploying your database in a container because, like you said, they're immutable. So you'd have to, anytime you wanted
Oh,
to update your database, you'd have to redeploy your application or redeploy your container.
and I've never deployed a a containerized instance of SQL Server, which theoretically you could have storage disks outside of your running container. But I really like Azure SQL and how easy it is for databases, and so I'm not even tempted to change SQL Server databases away from Azure SQL at the moment. All right, question: is this the same book that you passed out the last time that you were here? Okay. Was it? I believe it was because this book came out in 2019, right?
Mhm.
I think
Yeah.
I think I've spoken at the group since then.
Yeah, we had you actually for our first meeting, which was in, I believe, February of 2022.
Yeah, so same book. So, and yeah, just check your email. You might already have the digital copy. But if you don't, or if you lost it, just send me an email. I'd be happy. I mean, I'm not making my income off of book sales. I want people to learn, and if it helps, it helps.
And that's the great thing about digital content. You can just easily redistribute it.
That's right. That's right.
All right. Any other questions for Jeff? And feel free to come off of mute or enter it into chat. We do have one comment from Jeff, and he's saying, yes, this was really a great presentation. Lots to dig into. Completely agree.
Good. Glad it's helpful, and hope when y'all dig into the GitHub repository, it has some additional nuggets that I wasn't even able to cover in this time.
Yeah, no, it was very well done. So with that, thanks for presenting. And if you don't mind, I'm going to take back the screen for just a moment.
Yep.
All right. So in the chat, you'll see that there are several links to resources, and we'll cover them as we're going through it now. So first and foremost, the one thing that's on everyone's mind, is the meeting being recorded? Yes, it is, and will be posted on YouTube in just a couple short days after the editing process. You can subscribe to the YouTube channel and the link posted in the chat, and that way you'll get upload notifications whenever the video is uploaded. Also, the tech events that we'll be covering in just a little bit are posted on my blog. And again, the link for that is posted in the chat, and you can subscribe to that as well. And lastly, feedback eval. If you would please take a moment to fill out the form at the link listed there, so we can provide Jeff with some constructive criticism. For those that joined us after the start of the meeting, a special offer from Manning.com, 35% off using the discount code MTPCLEC21, and the link is posted in the chat window as well. So with regards to tech events, on March 16th, which is next Thursday, is the Great Lakes User Group for .NET, and they're going to be featuring Carl Franklin as they celebrate their 20th anniversary. And also on the same day is the Chicago.NET User Group, where I'll be presenting there for the, I'll be talking about adding machine learning to .NET applications. And then on March 23rd, which is the following Thursday, is going to be the next meeting of the Cleveland C# User Group. And for that, we're going to have Scott Hanselman doing a variety of different .NET demos. That meeting hasn't been posted yet, but soon will be. Also, with regards to conferences, on March 10th is the Global AI Bootcamp in New York City. That is a hybrid that is a hybrid conference, either in person or online, and it's going to be covering a variety of different topics related to AI. And then on May 11th through the 13th, giving you a heads up ahead of time, Global Azure 2023, and that is a free event that takes place over the course of 4 days, online, lots of great Azure topics, free of charge. There's also one, for some reason it didn't make it into the slide, but Star Trek. That's going to be happening on May 5th, and tickets are already on sale. And the link for that is stirtrek.com. The other thing I'd like to mention is job openings. So TechSystems always has jobs available at techsystems.com/IT-jobs, and always like to ask who's hiring and who's looking for work. So I know that Clear Measure is always hiring, right, Jeff?
And specifically, we're trying to hire a senior software engineer, senior .NET engineer, and a software architect as soon as we can find a good fit. So yes.
Remote positions?
Yes, actually we're 100% remote as of 2019. Just in time for 2020, we kind of realized that we were hiring outside of Texas anyway, and we made our headquarters remote, and then COVID hit, and we were already ready.
Nice. All right, so feel free to reach out to clearmeasure.com. If you have any job openings at your place of employment, or if you're looking to change places of employment, feel free to make yourself known either in chat or verbally, or you can reach out to me afterwards. And with that, my contact information, snasser@nistechnologies.com. You can also find me on Twitter @SamNasser. And my blog, as mentioned before, samnasser.blogspot.com. And if we haven't connected on LinkedIn, I invite you to do so. And so with that, thanks again to Jeff for a great presentation. Thanks to all who attended, and look forward to seeing you all at the next monthly meeting. Good night, everyone.